Good afternoon. It's interesting, I'm talking in front of two other people that are talking after me. One of them is in charge of my salary, another one is in charge of my research. So I have to be nice a little bit. So anyway, I think this is, I'm really pleased with the number of people that are attending this one, and we didn't expect that many, but it's really, I'm a member of a bunch of these in the past TRB committees, but this one is really a very good one because of the way that you guys are putting these several committees together and get annually together or every other year. It's really, that's a shortcoming sometimes we have in our committees that I remember. Sometimes we talk about the other committee, but we never get together with them. But this is really help a lot to organize a little some of our activity. You could see that the number, although we said 260, but actually is 270 now. And you could see the number of presentations. There's a good number of presentations, and with the field trip and workshop. These are the sponsor, and really that help obviously some of the bill that we have to pay. And another one just joined today. It's a H2 flow also that we don't have it there, but that's another team that helping. The committee that we have for most of you know these folks that they are, and I tell you that all of them, they contributed to the success of this program. But the one that I will probably mention is that specifically Cynthia. And I told her that if Federal Highway want to put a workshop or conference together and it want to be successful, just give it to her and that's it. Because I was planning to do a lot of work in this, but when Cynthia got involved and I saw what she can do, I said, oh, she doesn't need me. So in that case, really that was a big help for us. And a big chunk of the credit should go to her. The other person that from ODOT, Jeff Sire, because he's the one that his idea was to bring it here, and he's the one that worked with Ohio University. To just be a little biased, but he is a OU alumni. He's graduated the Ohio University, and so so he was really helpful in this one. And then we have obviously we cannot do anything that without support of our director of ODOT, Jerry Ray, and Jerry is one of those folks that really helping research for many years. I don't think so anybody will break his record because this is his 16 years as director of ODOT, because he was 8 years in one governor and then 8 now in the other governor. So that's, you're talking about 16 years, same person. And just because of he taking a lot of chances on research, he's the one that built invested $17 million to build this road, Route 23, that the data could use nationally. And all these things that he's really helpful for, particularly for universities, that we do the research, and he is really supportive of it. And so that's one of the, then Barna, he used to be a chief engineer. Again, he is a hydraulics major, so he was active, that's his area too. And he used to work with Jeff on the same topic. Then Dave, which is, will be one of the speakers, he's graduated from Ohio, the Ohio State University, but he is smart enough that we claim him too from Ohio University. But then he told me that his two or three children are OU, attending OU, so in that case, at least he pay for it if he's to Ohio University. And then on the case of the our team or Ohio University, I think one of the person that really helped, it was Bruce Shannon, she helped a lot. And I think it's without her help, we will not be where we are. She has pretty much handled most of the activity in Ohio University. And so he was working very hard on it. And then we have obviously other folks. Our dean was one of the person that, because once that ODOT could not sponsored this conference because of, when you have attorneys, they don't want to do anything. And so in that case, what's happening is that Ohio University, our dean and our folks there, upper administration said, "Look, we could take care of it and we will sponsor it by ourselves." So that's the way it happened that Ohio University is the main player in this one. And these are some of the people that they sponsor this. And these are some of the information that if you guys want to get, write down the note. And this is for people that they are worried about their meeting requirement for professional thing. So there is how they could handle that one. Okay, one other thing, since I have about 20 minutes that they said, is that what I want to do is that I want to show you a typical project that we did about 15 years ago, or almost now 16, 17 years, is that it was a partnership between federal highway, other state, include Ohio, and manufacturer. And we did this work on the area of the pipe, thermoplastic pipe. And now, after 15, 16 years, when I look at the literature around the whole world, that people in China or Russia or Europe, when they developing a design equation for thermoplastic, for their validation, they use this data that we generated in Ohio. And you could see that how this partnership paid off, that we did some work that it was not possible by one agency do it by itself. This was the manufacturer benefit from it, the state benefit, the federal benefit, and obviously the taxpayer was the final beneficiary. This is, just very quickly I will go, we call it a deep long-term performance of thermoplastic pipe. What I did is that I took about 1,800 feet of pipe, PVC and HDPE, and we buried under different kind of backfill, different height, anywhere from 20-foot cover to 40-feet cover, and heavily instrumented, because at that time, the question was is that if the pipe, when you're using a thermoplastic, is most of these pipes are viscoelastic, some of you probably know that. That means that they go relax or they go creep. And so that was always the question, because if it's creep, we cannot use it in the long term, these pipes. If it's relax, we could use it for 100 years. And so what we want to do is to prove that it's most likely relax if you put a good quality material around it. And so that, in that case, what we did is that we intentionally sometime, in some cases, we didn't compact it very well to see what happened if we don't compact it very well. A lazy contractor bury the pipe. And so we did that one, and we monitored it for almost 15 years. And these are some of the information on the project. And we generally, although we know who are the manufacturers, but we call A, B, C, D, those kind of stuff. But with the PVC and polyethylene, two companies from that produce PVC, and two companies that they were producing the HDP, EDS and contact, EDS and lane, or the HDPE, contact and violin is the one that PVC. This is the sort of a profile of the top of the if you take a picture from the airplane, that's will be the way it look like. Here it look like it's Ohio, it look like Arizona, a caveman type of thing, but actually it's not. The pipes are buried under 20 to 40 feet cover. And you could see these pipes. These are heavily instrumented, actually. You could see this instrumentation. We're measuring the deflection, horizontal, vertical, and what they call is a circumferential shortening. Also, we monitor that one. You could see after a month or 2 months, nothing happened after that. You get a deflection within a month, stabilize. Then after that, it just stays. So that means the pipe is relaxing. And that's the reason that these thermoplastic pipe could be used for long term, because if they wouldn't have this kind of behavior, we could not use it in the infrastructure. But that's one of their beauty, that if you could see that this pipe, we'll see what the diameter is. It is 60 inches, actually. You could see that after a month, it just stabilized. The PVC, with all kind of sensors we put in these pipes. Actually, what I did is that for some people that they are more structure oriented, I said if it's relaxed, if I go cut the pipe, the portion of the pipe will, that crack will not propagate. But if it's under heavy load, when I cut the pipe, the crack will go propagate. So what I did, I put a strain gauges and intentionally took a sharp object and cut the piece of the pipe under 40 feet cover to see what's happened. That crack didn't go anywhere. That means the level of the stresses in the pipe, it's not that much, because all is gone to the backfill. Relax. Then we have some other facility that we test the pipe, because that's something that we do in Ohio, is that some of them big manufacturers in Ohio. So we do a load frame. We could apply a load 1 million pounds to test the pipe in the ground for different purpose. We do that. We do concrete, plastic, and steel. This is one of the testing there. We even brought some pipes from Chile to test for that they were using it for copper mine. And so we brought even import the gravel from Chile to use it in our load frame to test how these pipes behave in copper mine in Chile. But the problem was, once we got the dirt from Chile, now we couldn't disregard it. We have to put it in landfill because the EPA wouldn't allow us. They said, no, that came from another country, goes to landfill. And so we've also laboratory equipment that we're testing. You could see that we built some robots sometime, because when we're working in the copper mine and all those, we cannot go there to measure, because we are dealing with a sulfuric acid when they do a copper mine. And so what we do is that we have all these robot type of thing that goes measure the deflection or the quality of air and all those kind of stuff. And then we have a truck that we could go and test the backfill material. There's a 30-ton CPT that we could look at the condition of the backfill of the 4x pipe. We have a mobile lab that we could go and for a pipe or for highways or anything. Basically, we have a 320 feet square lab that it goes any place we want to go. We could take that lab with us, and it's all kind of equipments are there, and we could use it for payment or we could use it for the pipe. And that one thing that you see, that's a ground penetrated radar. Has its own weather station and everything when we go to the site. Then one of the projects that we finished that is now for, most of the DOTs are voting on it. Actually, now it's in the ballot, is that using a recycled material for thermoplastic pipe. And we team up with that company from Texas, NCHRP Project, that we finished it. And what's happening is that now they are a ballot, so you guys are voting on it. And what's happening is these days everybody complaining about how much this plastic is damaging our waterways and the ocean and everything. I think once they approve this thing and we use more recycled plastic, probably we'll not have enough recycle to make all the pipes. And the advantage of that is that now using the plastic in place of damaging the waterways, we're improving it, because now we will deliver the water through these pipes for agricultures and all other activities. And that's that report, NCHRP, that you guys are voting on it. we have another, which I'll probably talk about it this coming Thursday, is the rerounding of the pipe. That's our new project that we are working on, rerounding. Our president from Ohio University will be giving a welcoming talk, and he is, one of the good things is that I worked in Ohio University for a long time, and when you are that long there, then you could meet different people. This is the first time we got a president that we can speak the same language, because he's a highly technical too. So in that case, it makes it a lot easier for us to convince him something we do, because we can talk with the thing. If you sit down with an art guy and you bring an engineer and he will talking about the pictures and we talking about something else. It doesn't work that way for us. And so we are really glad to have him. And he came from Texas Tech, and he was a president there. And I put his information on the board that you guys could see. When you become a president, you have to have a very impressive resume, and he has it. So it's really, he deserves it to be a president of Ohio University. And you're welcome to